record that. Let's stop it. All right, guys, this is your review working with properties of exponents, linear equations, and linear graphs. For this first problem, we want to solve for u. That original equation, we have -4/9 times u equals -24. And the way we solve this, we want to multiply both sides by the reciprocal. Remember, this reciprocal is when we reverse the fraction. The reciprocal of -4/9 is going to be -9/4. We multiply both sides of this equation by that reciprocal, so by -9/4. Okay, and when we multiply on the left side, -9/4 and -4/9, they cancel each other out, leaving u on the left. And that equals, on the right side, we have 4 and 24. We can divide 4 into 24 6 times. Carry that negative with the 6. So -6 times -9, we get our answer, which is 54. For example 2, we have this word problem. Leela got a prepaid debit card with $15 on it. She makes her first purchase and she buys ribbon. The price of the ribbon is 16 cents per yard. And after she made that purchase, she has $9.08 left over. We want to know how many yards of ribbon did Leela buy. The first step, you want to subtract. We subtract $9.08 from $15 to determine how much money was spent, and it's $5.92. Your next step, we want to convert the $5.92 to cent only. Every 100 cent is equal to $1. So the $5 we need to convert to cents. We multiply 5 times 100, that gives us 500, plus the 92 cent, that gives us a total of 592 cents. And since we know the ribbon is 16 cents per yard, we divide 592 by 16 and we get our answer, 37 yards. For example 3, we want to simplify this exponential expression. We have w to the -9th power times w to the -2nd power. If you multiply two exponential expressions with the same base, remember you're going to add the powers. So we keep that base of w, we add -9 plus -2, and we get -11. And that last step we need to simplify. Remember, you got to remove any negatives to make this a simplified exponential expression. To make that -11 positive, we're going to move it to the denominator. So it becomes 1 over w to the positive 11th power. Example 4, we have this exponential expression, 54 times y cubed times z cubed, and that's divided by 45 times y squared z cubed. What I'd recommend you do when you have a problem like this is combine the terms that are alike. So 54 over 45, we want to simplify that fraction. Separate it and then simplify it. 54 and 45 can both be divided by 9. 9 goes into 54 6 times, and 9 goes into 45 5 times. Now look at your y terms. We have y cubed over y squared. That's a division of exponential terms, so we can apply our quotient rule. Keep your base, and you're going to subtract the powers. So 3 minus 2, this gives us y to the first power, or just y. So we have that here. Write that right next to our 6/5. Now with the z term, we have, again, a division of exponential terms with the same base. We subtract those powers, 3 minus 3. That gives us z to the power of 0. And any term raised to the power of 0 is equal to 1. Okay, so that 1 times that 6/5 y is going to remain the same. This will be our answer, 6/5 y. For example 5, to graph the line of y equals -1, We're going to draw a horizontal line that cuts through the y-axis right here at -1. We plot that point of -1, and then we draw the horizontal line through the y-axis. For example 6, we are graphing this line here, -3x plus y equals 3. And remember, to graph a line, you need at least 2 points. So we find our x and our y intercepts. Remember, to get the x-intercept, at every x-intercept, your y coordinate is equal to 0. So what we did is substituted 0 for y. -3x plus 0 equals 3. That 0 crosses out, and we're left with -3x equals 3. We divide both sides of this equation by -3, and we get x equals -1. So we'll cross through the x-axis at -1. However, that ordered pair is -1, 0. We go up here and we plot -1, 0 on our x-axis. To get the second point, our y-intercept, we're substituting 0 for x. So that becomes -3 times 0 plus y equals 3. We're left with y equals 3. So that second order pair is 0, 3. We plot that point right here on the y-axis and then connect them to create the graph of the line.